and I showed you that this is a general Venn diagram. This picture represents all possibilities between set A, set B inside of a universe. Remember that rectangle is everybody we want to talk about. It represents disjoint sets, ones that have nothing in common. It represents equal sets when everything is in common. It represents subsets when one is inside of another. And it represents the last one, which I'm going to label as intersection. They intersect one another. They have something in common. So part of dealing with Venn diagrams is also set operations. We're actually going to perform operations on sets. Well, I'll give you two sets. It'll be like 2 plus 3, and you're going to give me an answer like 5, except in set language. And it's not too bad. The first one is intersect. Actually, the first one is complement. Complement is actually an operation, not between two sets, but an operation on a single set. And basically all it is all the elements that are not inside of a set. You remember this, right? When you say A complement, it is all the elements that are not in A. All the elements that are not in A. We've already talked about that. So that really is kind of an operation. But usually when you deal with operations, you want to talk about two of them. So intersection. Oops. The symbol for intersection is upside down U if you want to think of it that way. It's actually the same symbol as subset, just rotated. So it's an elongated C facing down. And what an intersection is, list all elements that are common between the two sets. You just have to list out what they share in common. Very simple operation. Let me give you an example. Let's see. Universe. Let's say, natural numbers such that all the numbers from 1 to 10, which is different than saying all the numbers between 1 and 10. They're all the numbers from 1 to 10. Let set A equal 2, 3, 5, 7. Let set B equal 1, 3, 5, 7, 9. What kind of numbers are 2, 3, 5, and 7? Prime. So that you could list that out as the prime number is less than 10. What kind of numbers are B? The odd number is less than 10. So if you wanted, you could put these into set builder notation and get fancy with it, but it's easier just to write them out. Now, I'm going to show you two different ways of dealing with this. One, just by looking at them, and two, by drawing the Venn diagram. What's going to happen is, looking at them works really great when they're small. Venn diagrams help out when they start getting kind of ugly and messy and so forth. So I'm going to show you both of them because I'm going to lean towards Venn diagrams eventually. So let's go by definition. I'm going to say, well, I'm going to operate on this, and I want to find A intersect B. When you see this symbol, you need to say, what's in common? What do they share? So what numbers do they share?
3, 5, 7.
3, 5, and 7. So you're going to list it out as a set. So you're going to get 3, 5, 7. And there's your answer. It's a brand new set. It's a brand new set because it's not A and it's not B. It's something different. Now, it could be A and it could be B, but more than likely it's not going to be. All right, Venn diagram style. Venn diagram requires you to draw circles for set A and set B. So you have A, you have B. Rectangle represents the universe. Whenever you're constructing a Venn diagram, you always start in the middle. You will start with, what do they share in common? Which is 3, 5, 7. So you put that in the I, and those are the elements that they share in common. They go in the I piece of the Venn diagram. What's left for A? Well, I got rid of 3, I got rid of 5, I got rid of 7. What's left?
2.
So he kind of is hanging out by himself, just A. What's left for B?
1
1 and 9. But that's not the entire universe. The entire universe is 1 through 10. So 1, 2, 3, 4 goes out here. 5,
6,
7,
8,
9,
10.
and 10 goes out there. So this would be the Venn diagram of the situation for this universe over here. Okay. Now, just by looking at this picture, I can answer what A intersect B is. It's 3, 5, 7. It's what they share in common. That's not what the Venn diagram is good for. The Venn diagram is good for this. What if I asked you for this?
What is 9 and B?
Now you have 2 choices. You can list out what A complement is. What A complement is. You can come down here and go, well, A's complement is equal to, well, it's definitely not 2, 3, 5, and 7, so that leaves 1, 4, 6,
8,
8, 9, and 10. Is that it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So A's complement would be 1, 4, 6, 8, 9, and 10.
So we took what was
Now-
not in B.
That's by looking at what's in the universe. No, not in A.
Okay.
This has nothing to do with B. This is what's not in A. So I don't even look at.
B.
I could care less about it. But here's the thing. Over here, you had to figure it out between the 2 sets, the universe and A. If you come over here to the Venn diagram, and you say what's not in A, all you have to do is cover up A. What do I have outside of it? Well, 1, 4, 6, 8, 9, 10. I can just see it. It's apparent, yeah.
The complement is always on A.
No, it could be on B. It could be on anything.
So is that A complement? So then you could put like B complement.
Oh, yeah, sure.
Okay.
If you want to list them out, I'm
So
saying
complement can complement anything, not just A,
you can't complement the universe.
and not the universe.
Because we don't want to go outside the universe. What I'm saying is the Venn diagram is actually easier. The complement of A is 1, 9, 4, 6, 8, 10. What's the complement of B? Well, if you cover up all of the circle of B, 2, 4, 6, 8, 10. It becomes real easy from the picture. So my idea is I do most of my work in the picture.
So
Rather
you
than-
never include the middle.
Yeah, that's what I was gonna
Oh, if you're talking about complements, don't think that, because then you're going to make a mistake with my next operation. In this case, yeah, because we're always covering up the middle, but that doesn't mean we're not going to include it later on. All right, so A complement intersects B. So A complement is, well, I'll list it out here. It's 1, 4, 6, 8, 9, and 10. And B is 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. What do they share in common? 1 and 9. So here, A complement intersect B is just 1 and 9.
So them 2 different answers we just did, right? Okay.
See, this is A intersect B. This is A's complement intersect B. What they have in common. All I'm looking for is what they have in common.
In the end, that's all you're looking for?
For this one, yeah.
Wait.
What if I have A intersect B's complement? Put it on the B. Now, A is 2, 3, 5, 7. I'm just going to list them out here for now. You're going to get sick of doing it this way. And I want to intersect this with B's complement. I think it's easier to go to the picture. Cover up all of B, the entire circle, and you get 2, 4, 6, 8, and 10. So 2, 4, 6, 8, 10. What do they have in common? 2. So A intersect B's complement brings you down to one element, which is 2. What if they have nothing in common? The empty set. So if you intersect 2 sets that are disjoint, your answer is going to be the empty set. Yeah. Kind of like the intersection of the even numbers and the odd numbers. What do they have in common? Nothing. Nothing. Because even they have to be divisible by 2, and odd pretty much says they can't be divisible by 2. All right, so that's intersection, mixed in with a little Venn diagram. Oh, I got my picture. So let's see. The next operation is union. For some reason, people get confused with union, even though the idea behind it is easier than intersection. But they want to do something special to it. The symbol for union looks like a U, so you should never get confused with it. Union goes with U. The other one is intersection. And this is pretty much put all elements together. I think of it as getting married. You have two people that get married, they move into one single house. If they have too many couches, they sell one. If they have too many chairs, they sell them. So any repeats kind of just get thrown out, and you just keep what you need to keep. So when we put all these elements together, we're just going to make sure that the elements exist in my final answer. So let me go back to A and B here. A was 2, 3, 5, 7, right? And B was, I forgot what B was. The odd numbers. 1, 3, 5, 7, and 9. So if I do A union B, the easiest way to do this is list out all the elements of A, and then include all the elements of B that you have not listed out of A. So you list out all of A and you get 2, 3, 5, and 7. That would be A. Now what elements have I not listed? Well, I haven't listed 1. And I haven't listed 9. Now technically, you want to put them in numeric order, especially for my test because I'm not going to play around looking for out of order things. So your final answer should be 1, 2, 3, 5, 7, 9 in order. So this would be A's union with B. Pretty simple, right?
I'm lost.
So
Why?
Why did you put the A like that?
Yeah,
My suggestion to you is list out the first one, and then go to the second one and just list off the ones that you haven't listed.
No, I mean, like, you have the A.
Oh, you don't need that. That's just me saying I listed A.
Okay, so but we need to
You don't need to
like
do that.
you have it at the
You
bottom.
don't need to do that. I'm just doing that for note purposes.
So you list A as it is, and then in B you list
Whatever you're missing.
Okay.
Whatever you have not written down yet.
Okay.
You want to include every element you see in A and in B.
No
Okay.
repeats.
No repeats. Don't repeat because that's
So
pointless.
that's all the union is.
Marriage.
Every element.
Every element you see. Just shove them together and put them in order. Just don't repeat. If one has a 2 and the other one has a 2, all I want to see is a 2. 1, 2. All right, now it gets a little confusing when we go Venn diagram style. Let's see here. Here's 2, here's 3, 5, 7. Actually, it doesn't get confusing. You can actually see where it's coming from. 4, 6, 8, and 10. Here's A, here's B. I'm only copying it down again because I'm going to erase it here. All right. What if I want to do A complement union B?
What's not listed in A.
What's not listed in A, put all together with what is listed in B. Now, my suggestion to you is go to the Venn diagram. You're going to cover up all of A, list out everything else. So the complement of A is 1, 4, 6, 8, no, don't forget the 9, and 10. If you cover up all of A, you're going to get 1, 9, 4, 6, 8, 10. Just put them in order. All right, union with B. B, of course, is the odd numbers. And all you have to do is put them together. Now, I'm going to do this a little different. I have 1, 4, 6, 8, 10, and I'm going to add in all the odd numbers, right? So the only number I'm not going to write down is
The E.
2. How do I know that? Well,
Because that's an A plus itself.
well, we have all the odds over here. We have most of the evens over here, and the only one that's missing is the 2. So my final answer is 1, 3, 4, all the way up to 10. The only number that is missing is 2. Do you see what's wrong with listing out the elements? If you're looking at these two and you're trying to find the union, you have so many elements to worry about that you forget which ones are in and which ones you need to keep out. So that's where Venn diagrams actually are going to help you out, because Venn diagrams could care less what the elements are. They only worry about where do you put them. Well, where do you put elements? Well, you put them in just A, you put them in the intersection, just B, and then whatever's left over for the universe. 4 sectors.
Okay.
So if you want to, you can back this off and say, well, what if I just want to deal with 4 sectors rather than 10 elements? It's a lot easier to deal with 4 than 10, right? Mathematics is all about simplifying processes to make things, well, easier. So let me show you one more thing before you get all fuzzy. Then, general. I can't even spell. I'm going to make the Venn general diagram very specific. It's going to look like this. It's generally going to be a very small picture. You're going to put a 1, a 2, a 3, and a 4. So the only places you can put elements in the picture are these 4 sectors. Or we can call this the sector diagram. These are the sectors. So when I talk about set A, what sectors am I talking about? 1 and 2. Inside the circle A is 1 and 2. If I'm talking about B, I'm talking about 2 and 3. All right, let's get confusing. If I'm talking about A's complement, 3 and 4. Take your thumb, cover up the entire circle of A, and you're left with 3 and 4. So this becomes 3 and 4. Later on, I'm just going to change these to regular numbers, but I'll color them so that they're not elements, they're sectors, and I'll treat them a little bit differently. B's complement, 1 and 4. These are all the possible answers. A, B, A's complement, and B's complement. So when I ask A's complement union B, watch what happens, this is cool. A's complement union B, I could care less what the elements are. I really could, because that really doesn't determine the answer. It's where they're located that determines the answer. So A's complement is 3 and 4. I'm going to write it this way. Sector 3 and 4. What's different? What's different between writing A's complement as parentheses 3 and 4 and A's complement as squiggly 1, 2, 3, 4?
That's it.
One's squiggly set, the other one is parentheses. We're going to read this as sector. So this is sector 3 and 4. Union, what's B?
3.
2 and 3. 2 and 3. So I'm going to say sectors 2 and 3. Yay! Now, I only have to deal with 2 things on the left and 2 things on the right, and all I have to do is shove them
Together.
and I get sectors
2, 3, 4.
2, 3, and 4. Now, if I go to this picture over here, sector 2 is here, sector 3 is here, sector 4 is there. The only element that's not going to be listed is
2.
That's how I knew 2 wasn't in there, just by looking at the picture. So all I have to do is list out all the elements in sector 2, sector 3, and sector 4. 3, 5, 7, 1, 9, 4, 6, 8, 10. I have my answer. All I have to do is put it in order. That's it. So dealing with the Venn diagram actually makes things a little bit easier. You might have to do a little extra writing, but it does make the problem easier, especially if you have many, many questions on the same problem. The book does group them that way. All right, let me do a different one.
So basically we just,
Don't erase that part now.
we just found the union of the general, of the Venn general diagram.
And the answer to that never ever changes. The answer for A complement union B is always going to be 2, 3, 4. No matter what the elements are, the answer to this is going to be 2, 3, 4. Which is kind of cool if you think about it. I have a guaranteed answer rather than different answers every time I set up a new universe. Let me give you an example.
Please.
Oh, I'll give you many today. For example, the universe is now I have no idea. A through L, a letter A through L. A is going to be B, C, E, G, H, J. B is going to be A, C, D, H, J, and K.
We still working with diagram.
What's that?
We still working with the same thing.
Same thing.
Oh.
Oh yeah, you're gonna get sick of this. All right. Now, if I ask you to find A's complement B, A complement intersect B, you could play around with this a few times and get the answer. But every time you play around with it, you have to play around with it for every single question, literally. I'm going to jump it right into a Venn diagram. Now, there's going to be the Venn diagram for the universe, and then there's the general Venn diagram. So you'll be working with two different pictures, but one of them is always going to be that. Always going to be that picture. This one is going to have elements inside of it. And this is set A, and this is set B. Where do I start putting elements inside of this? In the middle. So what do A and B have in common? C,
H,
H,
and J.
and J. So C, H, and J are going to go in here. Then you back off into just A. Now, there is a neat trick. You can go up here and cross off C, H, and J out of both of them, and then what you haven't crossed off, just write it down. But this one's going to have a B, an E, a G, right? Is that it? Yeah. And then over here, I can't use C, H, and J, so A, a D, and K. Am I done with my picture? Nope. Got to figure out what's left. I would highly suggest go in order and sing the song, you know, A, B, C, D. So, A is not up there. B, C, D. Oh, no, A is up there. I just saw it. A, B, C, D, E, F, G, H, I, J, K, L, we need. And that's it, right? Alright, so make sure you see all the elements. Look everywhere for them. Okay. And then I want to answer some questions, so I'm going to draw this little picture. This is just a very, very general one. I'm going to write my sector numbers in green. This, of course, is set A, and this is, of course, set B. And I want to answer A union B's complement. Now, I could come over here and figure it out, but it does take a little bit of effort, and there is some problems. There's 6 elements in A, there are 7 elements in B, and there's 10, A through L. I don't know. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 elements in the universe. So you'd have these huge lists. What's the probability of you missing one?
Very good.
Very good. It's actually extremely high. Either A, missing one, or putting one in that does not belong. But if you do it sector-wise, you're always dealing with 2 numbers until you get down to your answer. So what sectors are A? Well, A is 1 and 2. So I'm going to call them sectors, no squiggly lines here. These are sectors 1 and 2. And I'm going to union that with B's complement. Well, B's complement, if you cover up B, is going to be 1 and 4. How do you find a union? Shove them all together. 1, 2, and 4. All I need to do is go back to my picture here and pull off elements out of 1, out of 2, and out of 4, and list them out. So, elements. So, squiggly. B, E, and G. 2. C.
So these don't have to be in order?
Well, I will put them in order. I'm not going to do it. I would have a heck of a time trying to get them in order from the picture. So I'm just going to list them out and then put them in order. And then finally 4.
F, I, and L.
F, I, and L. Those are the elements I have as my answer. That is my answer.
Oh,
And I'm done.
I see it now.
You see what I'm saying? I don't have to work with the elements until I'm done.
Yeah.
So that's why you say use
The
the
general.
both the general one.
Yeah, I'm going to use
So you
the
would-
setup and the general, and I'm going to use the general to come up with the answer, and then go back to the setup and pull it.
I got you.
Okay.
Now, put them in order. A, B, C, D, E, F, G, H, I, J, K is not there. L, M, N, O, P. So L's the last one.
So
And that
we
would be
always use with the Venn general diagram.
1, 2, 3, 4.
1, 2, 3, 4.
1, 2, 3,
Always
4.
use it.
Every time.
Okay.
It never changes. That's the beauty of it.
Okay.
This
Sweet.
changes all the time. Because I can change the elements anytime I want. And put them anywhere I want in the picture. But those never move. All right, how about this? If I look at A's complement intersect B. A's complement intersect B. Sectors first, then the built-up diagram off to the far left. A's complement, what sectors am I dealing with?
The 3 and 4.
The
3 and 4. Because you cover up the entire circle of A, what's left over is sector 3 and sector 4. So here, 3 and 4 intersect B. What sectors are B? 2 and 3. That's inside the circle B. And the symbol between them is intersect. Intersect means, what do they have in common? And the answer to that is 3. So the answer to this is anything that's over here in sector 3, which would be A, D, and
Okay.
done. I didn't have to go through and list out all of A's complement and then compare it to B and then find what they had in common. All I have to do is look for the sector, the location that the answer will be in, and take the answer away.
Okay, I have a question.
Go for it.
Like for the test, with the example, we have to
Ooh.
break it down.
Now,
like
on
that.
the test, I have 2 problems. Number 1, you will have to come up with a Venn diagram on your own, but I don't ask any questions about it.
Okay.
Number 2, I'll have the Venn diagram designed for you with all the elements in it, then I ask the questions. I used to ask it as one question, but if you screwed up the picture, then all the answers after it were screwed up. So I kind of separated it into 2 pieces. One, I want to see if you can design one. The other one, I want to see if you can answer questions about it. Does that make sense?
Can you do an example?
I just did.
Okay, that's
That's what I'm saying. The test, I will give you the left, and you stop here.
okay.
And then I'll give you one that I've already drawn this out for you.
And then you break it
I'll
down.
ask you questions about it. That's it. That way, if you screw up the Venn diagram, it doesn't screw up your answers of the questions. Because people will screw this up and then it messes all the answers up afterwards. Jake,
Where does the 3 come from?
this 3?
Yes.
Intersection means what do they have in common?
So is it?
The only thing they have in common is 3.
You should
But I
know
was
it
still-
Why are you making this hard?
But we still have to break it down. Somehow you got to element. Let me see, up there at the top. We still have to break that down, or would that already be broke down to come
Oh,
to that
here?
specific? Yeah, that's what.
I gotta write this down, otherwise you can't do anything.
Oh, okay.
What, are you gonna make it up on your own? I want all the answers to be the same. If you
Okay.
make them up, they're gonna be different.
Okay.
Yeah, I gotta give you something. Alright, let's see. What else could I do here? How about, oh, I know. A intersect B's complement, complemented.
Wait, what?
Oh, complementary intersect B.
A intersect B's complement, complemented. Now, there's parentheses here. Same thing happens in math. You do what's inside the parentheses first, get an answer, and then worry about what's outside of it.
Is this the same problem or this something?
Same problem. I'm just
When
doing
you finish with that problem?
heck no. I can ask multiple questions about the same sets.
How did you know the A, B, K right
Here?
there? Yeah.
Because they're in sector 3.
So that
Sector 3.
Look,
Sector 3.
that stands for sector.
These are, when you have parentheses, this is sector 3 and 4, sector 2 and 3. Intersection of sector 3 and 4 and 2 and 3 is 3. Then I go to my picture and I say, well, what's in sector 3? A, D, K. Those are my elements. All right. So we're going to do the inside first and then work our way to the outside. What sectors are A?
1 and 2.
Notice what I did there?
Brackets.
I changed that big parentheses on the outside to a bracket so I don't get confused with these little parentheses. Intersect. What's B's complement?
1 and 4.
1 and 4. And then a bracket. And then there's this complement sitting way out front, or on top, if you want to think of it that way. Now, 1 and 2 sectors intersect with 1 and 4 sectors.
1.
There's 1. So I'm going to have this 1 on the inside, but this complement on the outside. 1's complement is, well, what's not sector 1? 2, 3, 4. Now, here's the cool part. This one was 2, 3, 4. Oh no, that's not the cool part. I messed it up. That's all right. Oh, I know what I did. Darn it. So, all I need is all the elements from sector 2, sector 3, sector 4. What are the elements in sector 2? A C, an H, and a J. My handwriting's horrible, I know. Sector 3, A, D, and a K. And then finally sector 4, F, I, L. And then you just have to put them in order, so we get A, B, C, D, E, F, G, H, I, oops, I, J, K, L. I'm just putting them in order. What, here? It's everything that's not a 1. And if you're talking about this picture, the only thing that's not a 1 is 2, 3, and 4.
So the question is at the top.
Uh-huh.
And bottom set is the answer.
The bottom thing is the answer. In order. In order. Yes, what?
So the complement outside and everything, that would be like 1. Wow.
Wait a minute.
Okay, right.
The answer on the inside is 1. What do these two things have in common? This has a 1 and a 2. This has a 1 and a 4. And the only thing I said twice was 1. So the answer to the inside is 1. This complement has just been hanging on in the outside. So what is not a 1 in that general picture? 2, 3, and 4. Why are you making this hard?
Because it is.
No, it is not.
Not to you.
No, not to anybody. All right. That is 2, 3. That's the end of 2, 3. Well, there's one more small piece. One more small piece.
Are we still on
This is still 2, 3. It's a tiny little piece at the very end of it that I always forget, but I always find it later on. And there's another way of doing it. So, yeah, N means cardinal number. So in English, this means the number of elements inside of set A is 5 of them. There's 5 elements. 1, 2, 3, 4, 5, A, B, C, D, E, something like that. The number of elements in B is 7. Can you tell me what the number of elements in their union is?
Yes.
Really? It's always going to be 12?
No.
Ah.
What's in there?
Let me ask you a question. In that last setup that I had with the letters, how many elements were in sector 1?
9. 3.
3. How many elements were in sector 2? 3. How many elements were in sector 3?
3.
Really?
Yeah.
Boring. How many elements were outside?
3.
Oh, that's really boring. Okay. Now, in this picture, how many elements are in set A? 6. How many elements are in set B? 6. And 6 plus 6 is?
12.
But how many elements are in A union B? 9. So just adding them together is not going to work because there might be some that they share in common. Okay.
So
So what's the answer?
Oh, well, I can't tell.
Oh,
I'm missing a piece of information.
oh.
You need one more piece of information to solve this. So you need the number of elements in A intersect B. You need this. Because you have to know which number you're counting twice. See, when you say the answer is 12 up here, you're counting 3 plus 3 and another 3 plus 3. But you counted that middle 3 twice. So let me draw a picture of this one. Here's A. Here's B. Ugh, that's an ugly one. And let's say the number of elements that they have in common is 3. If I'm going to design the Venn diagram for this, the 3 is going to go in the middle. There's going to be 3 elements there. How many elements are going to go just in A?
5.
But then 5 plus 3 is 8,
2.
and there's only, so there can only be,
2.
because 2 plus 3 is 5. See what I'm saying? This is where it gets weird. You have to worry about it because A is getting separated into 2 pieces, just A and what it shares with B. And when you say the number of elements in A, it's both those pieces. All right, so what's left for B? 4. Now, how many elements are in A union B? 2 plus 3 plus 4 is 9. So then this becomes 9. But I need to know that intersection. There is a formula.
So the difference, you still came out with 9.
No, wait a minute. Before, people were saying 5 plus 7 is 12.
Yeah, I'm talking
Oh,
about
this is a different picture.
Okay.
This is a different setup. This was the last one that we did. We knew how many elements were in there. Kwame. Message system surface now. There is a formula for this, but I highly suggest you don't memorize it.
Well, don't understand.
Well, then you don't need to
Some
tell us
people-
about it.
Some people like formulas. I highly suggest you draw the Venn diagram, you put the numbers into it, and you just add. The formula says take the first number, add it to the second one, but take away their intersection. So 5 plus 7 is? 12 minus 3 is?
9.
It brings you back. But I'd rather you just draw the Venn diagram and go from there. That way you don't have to memorize the formula.
Can you do one more, please?
No. They're not that important. It's just a tiny little piece.
If you not see them on the test, you
Oh,
know, like,
the last section of this chapter, we'll go over it. It gets worse though. But most people like it. Do they? 2, 4. Well, don't want to use the word equivalent. Equal. Venn diagrams with 3 sets, plus I want to give you an equivalence relation. It's called an equivalence relation, but it really in set theory it's equal. It's equal. So if I have 3 sets, and I need to draw it out in a Venn diagram, the picture is going to change a bit. It gets a little deeper. And what I consider this is the Mickey Mouse picture. There's the 2 ears, and there's his face. You have to draw this in such a way that here's where you have to be a little cautious. You have to have enough room here in the middle to put elements. You have to have enough room in all these 3 pieces next to the middle to put elements. Most people make these pieces, the ones on the outside, really, really big, and the ones on the inside really, really small. Don't do that. The ones on the outside usually don't end up with that much because they're taken away from the middle. We'll call the top 2 A and B, just like the other general Venn, and the bottom one C.
C.
And then, of course, the rectangle is the universe. Isn't that a pretty picture?
No, it's a confusing picture.
Oh, well. So, let's say we have a universe. I'll show you how to design one first. X, natural number such that 1 is less than or equal to X is less than 16. Always reviewing. Let's set A equal 1, 3, 4, 7, 9, 11, and that's good. Let's let B equal 2, 3, 5, 9, 13, and 14. And C is equal to 1, 2, 3.
Are you making this up in your head?
Yeah, why not? 5, 10, 11, and 14.
You get a kick out of it.
Just throwing numbers at it. And again, I have to, if I'm going to ask you this question, to design a Venn diagram, I have to give you that. I'll even draw the picture for you. I don't want to see your messy circles. Okay, so where do I start my Venn diagram? Smack dab in the middle, the intersection between A, B, and C. So that means all the elements that all three of them have. I'm going to be really careful with this one. Do they all three have a 1?
No. It's
No.
only 3.
Well, let me get there. Do they all have a 3? Yes.
Yes.
What I'm going to do, because this gets messier, is I'm going to cross off 3 out of all of them so I never ever write it again. But I do write it in the middle. 3. 4, do they have it in common? 7? 9? 11? So the only element that goes smack dab in the middle is 3. Then you kind of back out. I'm going to move up. This becomes the intersection of A and B. What do A and B have in common? Do they have 1?
No.
4? Don't say 3 because it's gone.
They have 9.
4? No. 7? No. 9? Cross it off. Put it in. Between A and B, they do share a 9. Do they share 11?
No.
Then that's it. See, if I just use one set to compare, then I can find all the ones that they have in common. Then I'm going to move over here to the left between A and C. So top to bottom, do they have a 1 in common?
Yes.
Kill it, write it. Do they have a 4 in common? 7, 11. Kill the 11 out of both A and C, but write it. And don't write it as 1, 1, 1. 1 comma 11 comes in handy. All right, so that's between A and C. What's left?
B and C.
B and C. Now notice what I'm doing. I'm working my way from the inside out. I don't jump into just A, just B, just C. I have to work between all their combinations. So between B and C, the bottom two, do they have a 2 in common?
Yes.
Kill the 2, write the 2. Do they have a 5? Kill the 5, write the 5. And 14. Oh boy, I didn't leave myself enough room. 14. Like I said, leave yourself enough room. All right, so 2, 5, and 14 go into that little sector. Now the nice thing about crossing them off is it makes the end of this problem really nice. When you say, what's left for just A? 4 and 7, just write it down. 4, 7. And then B, a lousy 13, bad luck guy. And then lastly, C is 10. Makes it very simple for those 3 pieces. Lastly is the hard part, the universe, what's left over. So, in order, 1, 2, 3, 4, 5, 6 is missing, so I need to write it. 7, 8 is missing. 9, 10, 11, 12 is missing. 13, 14, 15 is missing. Is 16 missing?
No.
No, because 16 is not even part of the universe. Notice it's not equal. It's just less than. So 16 isn't here. Don't write it. My favorite test question is I'll say 1 is less than x, and then people put 1 in the set. Is 1 less than x? No.
That's what you just said.
X would have to be 2, 3, 4. So you got to be careful. Don't just assume some values are there. So here's my picture. Yay! It tells me everything. Now, second question. If I'm going to come up with a sector picture for this, how many sectors would it have? Close.
8.
8. Don't forget the universe. 1, 2, 3 straight across the top. 3 straight across the middle. 1 down below, so that's 3, 3, and 1, which is 7. And then the 1 on the outside. So a general picture will look like this. 1, 2, 3. There, I made my sectors bigger that time. And in here are sector 1, sector 2, sector 3, straight across the top. 1, 2, 3. You have to number it exactly the same every single time, otherwise your answers will get a little weird. This is 4. 5 is the one that's in common between all of them. 6, 7, and then finally 8. It works exactly the same as what I showed you with 2 sectors. For instance, real quickly, what if I asked you A complement intersect B? Intersect. What do they have in common? Now, I'm going to go to the sector picture. I'm going to write B first. What sectors are B?
2, 3, 5, and 6.
2, 3, 5, and 6. It's all the elements or all the sectors inside the circle for B. So this becomes 2, 3, 5, 6. B will always be 2, 3, 5, and 6. Now, with 2 Venn diagrams, we worked with 2 numbers all the time. When you're working with 3, you're always going to be working with 4 sectors. So when you start these off, you better have 4 numbers for every single letter. For A, for B, and for C. They should have 4 each. So A complement then should have 4 numbers. What 4 numbers?
3, 6, 7, 8.
3, 6, 7, and 8. It's everything that's outside that circle. So this becomes 3, 6, 7, 8. And we're intersecting these sectors and saying, what do they have in common?
6.
3 and 6. So to answer this question, all I have to do is list out all the elements in sector 3 and all the elements in sector 6. So what are the elements in sector 3? 1, 2, 3. 13. So 13. Sector 6 is here. 2, 5, and 14. Which is easy enough to put in order. 2, 5. I wrote 5 first. 2, 5, 13, and 14. And there's your answer.
Oh, man.
Now, if you were going to go the other way and just use the elements, it gets really messy. Quickly. Very quickly.
Okay, Mr.
And intersection is easier than union for some reason.
Okay, you see how you put the squiggly lines and then just the parentheses on a test or any quiz? If we happen to put parentheses, that's you will mark it wrong.
Because I need to read the set of. Remember these squiggly lines, the braces? They're called braces. They read the set of 13, 2, 5, and 14. Here it reads the sector 3, 6, 7, and 8. So yes, the language is very important. You put parentheses where they're supposed to be squigglies, I'll take a point off. Of course, I'll be happy if you have the right answer. Answer-ish, I should say.
Where does the 14 come from?
Where's the 14 come from?
It's in there.
It's in there.
It's right in there at the
It's above
top.
my 2 and my 5 here.
I thought
It's right there.
It's up there.
This is sector 1, 2, 3, 4, 5, 6, and sector 6 has 2, 5, and 14.
does that box around it mean that's the answer?
For me. Oh, by the way, if you have messy work where you work all over the place and your answer is buried in there someplace, put a box around it. That way I can go, oh, that's what you mean, here's your last answer.
Okay.
I'm eventually going to make that a requirement for all my classes. Because I have people doing a little work here, a little work there, a little work here, and they expect me to find the answer. I don't like witch hunches. Not witch hunts, what is it? Scavenger hunts. Scavenger hunts. Where's the answer? Alright, let's make it worse.
What?
Oh, did I say worse?
Yes, you did. That's it.
No, that's not it. That is not it. Well, I have 2 directions I have to go. This is one of them. So I'll stay with this one for a little bit longer, and then I'll switch gears and go a different direction. New set. Universe. A, B, C, D. Let's go all the way up to N. A, B, C, D. Set A, C, E, F, H, I, M. set B, B, D, E, H, J, L, C, A, B, C, G, H, I, M, N. Now the drawing. So we do the Venn diagram for this universe. Let's make sure my circles are nice here because I have a lot of elements. There, that gives enough space for the little baby pieces on the inside. This is set A, set B, set C.
What is that, A, B, C?
A, B, C.
And G, no.
No. This is capital A, capital B,
No,
capital C.
The pen was fading in C. What's that? A,
Where are you?
B,
Oh,
C, G.
A, B, C, G, H, I, M, N.
Okay, thank you.
I know, I need new markers.
Yeah,
The cool thing about the screen is it could care less.
I know.
So, where do I start this picture?
Second 5.
What do they all have in common? A?
H.
No. C? No. E? No.
H.
F? No. H? Kill the H?
Yep.
Write the H. Goes right smack dab in the middle, sector 5. I? M? No. So the only letter that goes smack dab in the middle is this silly little letter H. Move up into, oh, you guys have a little bit better. H. Move up into A and B. Do they have an A in common? C? E? Yes. Kill the E, write the E. F? I? M? Good Lord. Nobody's in common. Between A and C, top to bottom. A? Kill the A. C?
Yeah.
Yeah. Kill the C. Who goes here? F? No. I? Yeah. Kill the I. He goes here. M? Yep. I gotta squeeze an M in here. So ACIM goes in there.
Okay.
ACIM.
A-C-I-M.
ACIM.
So you
That's a
can
man.
you can say A to B to A to C. How you
What?
when you get
A to C.
A to C? That's
Yeah,
what
that's
It's
A to C.
in the right place. It's no way to go.
Over here, it's B to C.
What happened to the C, Mr.
Yeah, you missing the C.
You missing the C.
Okay.
It's right here.
I mean, I should make my.
Oh, that's over the I. That make it look like an
Yeah,
L.
like a.
Oh, I'm sorry. Arrow. That is ACIM.
Excuse me.
Okay, it's not an F. My F is cursive type. All right, what's between B and C? So the bottom two. Do they have a B? A little B in both of them, so a little B here. D. J. L. Ah, wow. So what's left for A? F and, well, F. F. What's left for B? D, J, L. D, J, L. What's left for C? G, N. N is Nancy. That's an H. All right, now to find out what's left. A, B,
It's just K.
C, D, E, F,
G.
G, H,
H. L. J.
I, where are you? J,
K.
K,
That's it.
and then L and N is there. Okay. H is in the middle.
It's just K. It's K.
Numbers are so much easier to work with. All right, general picture, general set diagram.
I'm on the board.
Put the sectors in green. 1, 2, 3, 4, 5, 6, 7, and 8. Obviously ABC. And I want to find, you're going to hate this.
Wait a minute,
Don't
what are
do
those,
it.
now
Wait.
what if they just put up there sectors, right?
1, 2, 3, 4, 5, 6, 7, 8.
I can't. s-
1,
I
2,
can't see
3,
no one.
4, 5, 6, 7, 8. That's a 1.
Two.
So, let's keep it simple for a second. A complement union B intersect C's complement.
What? How you say it's gonna be simple?
I did. It's simple. Yes, you're going to work inside parentheses first. But before you start working in parentheses first, you're going to replace every one of these letters with their sectors. You're going to replace every letter with its sector value. So what sectors are A's complement?
3, 6, 7, 8.
3, 6, 7, and 8. After you cover up all of A, this is 3, 6, 7, 8. Union. I'm going to change this first parentheses into a bracket because I want to have more parentheses on the inside. B, what sectors? 2, 3, 5, 6. That's not going to change. Intersect. C's complement. Cover up C,
1, 2, 3, 8.
and you get 1, 2, 3, and 8. Bracket. Now, you do have to work on the inside of those brackets first before you touch the A on the outside. So when you intersect, what are you doing?
Combine. What I got in common?
What do they have in common? Am I touching this first one?
No.
Just write it down again then. 3, 6, 7, 8. We're going to union that with the answer over here. What do they have in common?
2 and 3.
2 and a 3. Now, I have a union between these two. So all I need to do is shove them.
Together.
So you got a 2, you got a 3, you got a 6, you got a 7, and you got a 8. Now the answer to this is going to be horrid. Horrid. But it's not hard to get, it's just writing it down is going to be bad.
That's not that.
Pick all the elements in sector 2, which is E. All the elements in sector 3, D, J, and L. All the elements in sector 6 is just B. All the elements in sector 7, G and an N. All the elements in sector 8.
Okay.
And then all you have to do is put them in order. Ta-da, done. It didn't take that much effort. Now, if we went the other direction, list out all the elements of A's complement. List out all the elements of B. List out all the elements of C's complement. Put B and C's complement together and come up with all of those elements. How many elements would we be dealing with? Too many. Much more than what I've done up here. So in order, this becomes B, D, B, D, G. Not B, D. A, B, C, D, E, F, G, H, I, J, K, L, and
That's it.
I hate alphabet. I can't do things in alphabet. Oh, finding things in a dictionary? Boy, math people aren't good at that. Phew.
Homework. Let me guess. It's not it.
What time is it? It is 10:43. I got 2 minutes.
Come on now, homework.
Wait a minute. One simple picture. 1, 2, 3, 4. Set A. Set B.
Just another example?
I want you to do this one real quick.
Okay.
I just want the sector answers for those two.
Alright, give me a second.
I got a question.
What is your question? What is
Yes,
it?
totally.
1,
I want you to give me the sector answers for those two.
3.
The one you just did,
Uh-huh.
inside the brackets,
Uh-huh.
that's intersect, correct?
That is intersect.
So that means you only use 2 and 3.
What they have in common.
Right.
So, yeah, 2 and 3. This symbol is put them all together.
Gotcha.
Just and get rid of repeats. Get rid of repeats. We don't have a lot of time. So what sectors are A's complement?
3, 4.
3, 4. What sectors are B?
2, 3.
2, 3. If I union them together, I get
3, 4.
2, 3, 4. Woohoo! You should be able to go somewhat quickly through this. 4 numbers, that's all you're dealing with. Over here, bracket to begin with. A is 3, 4. No.
No,
1 and 2. You're going to intersect that with B's complement, which is 1 and 4. And then you're going to take that answer and complement them. Intersection means?
Common.
What do they have in common?
1,
A 1. And then I'm going to complement it, and that gives me?
2, 3, 4.
What's true about these two answers?
Uh,
They're exactly the same.
You're not gonna add these in subsets and sets and prop sets.
No, you can't.
There's no squeaky
Well,
wheel.
no, I rephrase that. You
Well, don't.
can, but they turn into true-false questions.
If you just want to say,
So the answer to that is,
The answer to that is A complement union B is the same thing as A intersect B's complement complemented.
yes, it's so
Now, here's the question. Which one looks nicer?
The first one.
The first one. So if you see the second one, you can always change it to the
first one.
how. Well, here A is by himself, so you're going to complement it, A complement. The intersection becomes a union, and the B complement complemented becomes just plain old B. That's like negative B, negative, negative, negative B. This is called De Morgan's law. And we'll spend a little more time on that next week. But it is a cool little law. It allows you to get rid of complements on the outside and bring them into the problem.
Where did you get the bottom 2, 3, 4?
Oh, here?